Morning. How are we? I'd like to first apologise for my accent. I speak with a really broad Irish accent. There won't be any subtitles, so don't wait. Thanks, Roger. I'd like to just carry on this series to talk about electronics and the importance of electronics, because what we tend to do is we get fixated on the light source. Any specifications we write are all written around the light source: CRI, lumen output, whatever else you want to, wherever else you want to put in, L values, B values, whatever else comes to your mind, they're always the light source. So I'm going to start off my part in this to ask you a question. You all use laptops, computers? Yeah? Those of you who have heard this presentation before, you know the answer to this. Stay tuned. So you all use computers. You all understand what computers are. What's the most important thing inside a computer? Battery. Excellent. The battery. Anybody else got anything? When you're buying a computer, what is it you look for? Resolution. Say again? Resolution. Yeah, resolution. Screen resolution. Very important. Anything else? Speed. Processor. Yeah, fantastic. Anybody got anything else? Memory. Yeah. Memory. All very, very important. But what is singularly the most important thing inside a computer? No. The fan that cools the chip. If the fan that cools the chip stops working, the computer, the laptop, it all stops. Doesn't matter how fast it is, doesn't matter how good the resolution is, it all stops. When was the last time you said to the man in Curry's with the badge that says, "Help me, how good's your fan?" So I drew this conclusion just to point something fundamentally wrong with what we do, which is, what's the most important thing with an LED luminaire? Is it the LEDs? We're fixated. No, it's actually drivers. Electronic stability. When was the last time in the specification we actually put that you should supply a data sheet for a driver? What are the cooling features of the driver? Because they need thermal stability as well. How does the driver work? In real terms, L70, 50,000. Fantastic. That's really, really good. But your driver's only rated to 35. What does that mean? So I challenge you to actually try and understand what drivers do. So I'm going to give you a bit of a spiel, and I've only got like 12 and a half minutes to do it. So this is a compressed version, and I'll take you through it. So why do we need drivers? Absolutely. Fundamentally, we need drivers because of the way the LEDs need to receive their power, and obviously output current needs to be matched by what's required by the LED in the application. So what we have is drivers either will be constant voltage or constant current. And if for 1 minute you think that all drivers are the same, you're much mistaken. And if you think for 1 minute that because it's 350 milliamp current is required, you can just get a 350 milliamp driver and just plug it in, you're much mistaken. The people in the white coats at Tridonic, who are part of our group, told me, and these aren't lighting people, these are guys called doctor and professor. And they understand the dark arts. So they explained it to me in very simple terms. It is a symbiotic relationship between a driver and an LED module or a board. It's absolutely fundamental that you get it right. So anyway, you look at whether the voltage is 12 or 24 volt. You take all these things into account. And what driver types do we have? Well, we obviously have them set into different groups. So we set them into the following groups. We have by wattage, absolutely. By output or current voltage range. By case type. That's important as well, down to the design of the luminaire. And by dimming or by fixed output. So these are some of the criteria that we generally split the drivers into. And obviously, if you have an IP-rated luminaire, having an IP-rated driver might be important. SLV and non-SLV. So what are the driver types? Control signals. Dimmable drivers accept a variety of control dimming signals, including the following: 1 to 10 analog, Potentiometer. I always think, when I hear that, I always think of the old Frankenstein movies with Igor going, leading and trailing edge phase cut, switch main, switch dim, and DSI, and finally the one we all know, which is DALI, which was invented to do lighting and control lighting. Power line communication is there. It exists where the control signal piggybacks on the back of the mains board. So driver and dimming outputs. So we all know that LEDs don't necessarily dim. We use a thing called PWM, which is pulse width modulation, which means the LED switches on and off quicker than the human eye can see. Yes? Always very visible in the when Audi released their brand new top-end car. I forget what it's called. Anyway, sports car. They showed the video on YouTube, and every time the car braked going around the corner, the LEDs flashed on and off. Same thing happened at the London Olympics in the Velodrome when they brought the sky cameras in. They didn't realise that the cameras can pick up the pulse width modulation. Please never, ever use a mobile phone and point it at a light fitting. Don't ever, ever do that. That just shows that you don't know what you're doing, so don't do it. What happens is the refresh rate of the camera's different than the refresh rate, and you get flickering. Oh, look how badly that flickers. Please don't do it. Anyway, so pulse width modulation, you get very, very low color shift. You get hardly any no brightness tolerances, but you have a risk of flicker and stroboscopic effects. With certain control systems, if you use PWM below 20% or 15%, you'll find that you can have issues. Now, the issues of flicker are difficult because, one, there is no known industry test for flicker. Two, there is no known industry value for flicker. People will say, yeah, 15% from Public Health England. Yeah, but that was based on fluorescent. 15% is not that good. Then you get some people saying, yeah, it's 5 or under. Where that comes from is Sky, BBC, super slow-mo, high-def cameras. The Luminaire has to have a flicker percentage of less than 5%. So we're kind of struggling a wee bit. But the other problem is 1 in every 1,000 people can perceive flicker. There's a good one. Because we all know you don't see with your eyes, don't we? We all know that. You see with your brain. Your eyes are just a collimator. And what happens is the eye accepts the image inverted. So if you didn't have a brain, everything would be upside down. So there's a hole there. So what happens is 1 in every 1,000 people, their brain actually perceives flicker. They can't see it, but it upsets them. And that's a difficult thing to deal with. So flicker and flicker perception are difficult. What we found is we've used amplitude dimming, which is an analog, almost like an analog dim. And what we find it is almost flicker free. And it has brightness tolerances at very low levels. The best way to control LEDs on a dim function is to sometimes have a hybrid driver, which is pulse width modulation down to a certain level, and then below that is analog. Compatibility guidelines. So this is where the guys from Tridonic said to me, here's what we do. Here's how we test compatibility. I'm very quickly going to go through this. You don't need to understand what it is. You just need to understand what the content is. So what values need to be checked? We need to check current, voltage, frequency and repetitive current, and then non-repetitive peak current, and then power. So we need to check all these things. How do we do it? We take a module and we take a driver. And what we do is we compare off the data sheets. Will the comparison match? So what we find is we check the data sheet of the LED module. We find out where exactly we need to be on the current. We see that there's at a junction temperature of 85 degrees. We see that there is a value there. There's a current that goes along with it. We then go back to the control gear and we check the same values on the control gear, that they are in fact exactly the same. and they are. That's a tick for current, and so on. We go through voltage, and we look at the typical voltage at the junction temperature that we require. We look at driver selection voltages. We make sure that the two match on the value. We go back to the control gear, and we see that those two values are exactly the same. So they indeed match. And so on. So we go through all these versions of do they match, do they match, do they match. And in some cases, what happens is, as in the case of our company, we used a Phillips driver in some of our Luminaires because it was the right one to use. It was the best one to use with that particular board. So what I'm trying to suggest to you is that this doesn't happen by accident. It's not like you trip over a driver and go, yeah, that one will do. Let's just plug it in. It doesn't work that way. And I suggest, as in everything else in life, you get what you pay for. You need to make sure that all these things actually do match and actually do work together, because the phrase I'm going to give you is electronic stability. It's not does it turn on. It's not does it stay on for the first few hours. It's stability across a time frame. So you're talking about L70, 50,000. If I say 7 in the morning to 7 at night, what is 50,000 hours in years? Anybody want to have a guess? 5 years. No. No, you're all shaking your heads. You don't want to do the math, do you? No. No. 11 and a half. So at the end of 11 and a half to 12 years, that's the time frame you're talking about. So electronic stability is not important in year 1. It's as important in year 12. And my suggestion to you is that if these electronic stability checks have not been done, or have been sidestepped, or have just plumb been ignored, then your electronic stability is never going to take you. I could say, I drive a red Ferrari and I've got pictures of me driving it. I'm a big fan of take me outside and let me see it. So I would be suggesting that even if I have a data sheet that says that this Luminaire will last for this amount of time, I would suggest that you dig further. I would suggest that you find out that there is, in fact, electronic stability. So once you've checked all these things that they match, you can then say the combination of the board and the driver do actually match. Do we think that every company does this? Do you think when you pay 20 euros, you get 20 euros worth of stuff? Please be aware of that, because the marketplace thinks you can get 100 quid's worth of stuff for 20. Doesn't work. Ripple current is 4 reasons why ripple current appear. Direct visibility. Ripple's generally perceivable up to 120 hertz. Almost every reputable manufacturer would not release a Luminaire onto the market that flickers. Surprise, surprise. We wouldn't do that. Indirect or perceptive, it's a subconscious effect. It's really strange. It's really strange because you know when you walk into somewhere you can go, yeah, something not right here. I can't visibly see it, but I can feel it because light has an impact visibly and biologically. So you need to remember that. Health implication studies have shown that health problems related to lighting and building. In the old days of early fluorescence, it was a nightmare. It really was difficult. But as manufacturers, we changed a lot of what we did. So compatibility with other devices. Please remember that really high quality CCTV, high def, super slow-mo cameras can see a lot of things that you can't. So please be aware of compatibility. Obviously, high ripple can cause flicker, visible to the human eye. Obviously, we wouldn't get involved in that. But extra low voltage, safety extra low voltage, please make sure that it is labelled. I've stated the driver in the data sheet and the label that it conforms to what it needs to conform to. And then finally, protection and lifetime. A good driver will have various forms of circuit protection. This is the phrase, a good driver. A good driver design will have these things. We'll have LED overload protection. We'll have over temperature protection, short circuit protection, mains burst surge immunity. And some drivers will also monitor the operating temperatures of the LED via an external sensor and will dim the LED in order to reduce the temperature if it's too high. So you get that level of detail, that level of intelligence, but obviously you need to make sure that these things actually function. So what I would suggest is, when it comes down to driver selection, assuming that the compatibility is checked and it's okay, the following further points. So the work and voltage range, the efficiency, the power factor, the harmonic distortion, time to light is important. Output current tolerance, type of dimming output, maximum output voltage. These are all the things that the people at Tridonic said to me that was important to look into. Do we look into any one of these? Nah. Should we look into them? Well, it's maybe not for our level of knowledge base to look into them, but I would suggest to you that the further up the scale you go, the more of these things get contained. Would that be right to think that? Yeah? So, to conclude, people always ask me, well, what do we do? What can we do? Because we're professionals. Unless there's somebody in here who does a bit of window cleaning on the side. We're all professionals. So what can we do as professionals? One, definitely documents and certificates. Find out, get a data sheet for the driver. Find out the information. Make sure there is compatibility. Make sure what you're buying is actually functioning. Secondly, guarantee. I love this. When I do this bit, can you imagine I have a blue cape flapping in the wind and I have a pair of red trunks over my trousers? People go, yeah, I've got a 5-year guarantee. Not so have I. My dad's bigger than yours. I've got a 5-year guarantee and mine's better. I've got a 10-year guarantee. I heard recently somebody giving a 20-year guarantee. Please don't be stuck in the 5-year guarantee. Don't go must have 5-year guarantee. Absolutely not. Look into what the guarantee covers. You're better with a good 5-year guarantee than a rubbish 20-year guarantee. So don't be taken by the length of the guarantee. Be taken what it actually covers. Make sure that you're comparing apples with apples, to steal Roger's phrase. Obviously, the relationship between the board and the electronics. Understand how important that is to the electronic stability. And in the end, a reputable manufacturer. You'll find that reputable manufacturers do these things as a matter of course. Thank you.